so let's take a look. So you made your number line, and then 14, 27, 40. Your number line should be by tens. 10s, 20, 30, 40, 50, 60, 70, 80. Everybody understand that? Don't go putting like 14 or 27 or weird numbers in there. Just go by tens or by 20s. 55, 73. And then I'm going to draw a box through the 3 in the middle and out to the ends. Good? Okay. Now we're going to talk about outliers. Brandon, now read.
Outlier is a value that lies very far away from the vast majority of the other values in the data set. An outlier can have a dramatic effect on the mean and the standard deviation. The data value less than Q1 to
Minus
minus 1.5
IQRs.
IQRs are greater than Q3 plus 1.5 IQR can be considered an outlier.
Right. This IQR is the interquartile range, which we talked about a little bit a minute ago. We're going to talk about it a little bit more. Here's an example. So I need to, here is my data. Let me figure out what my, I can split it perfectly in half. I need to figure out what my Q1 and my Q3 are. So here, I have an odd number of data items in my lower half. So I just have this as my Q1, right? And this is my Q, oops, I should probably not overwrite 10. This is my Q3. So my IQR is, again, Q3 minus Q1, so that's 10 minus 4. 6. Everybody on board with that? Here's the deal. I want 1.5 IQRs because here's my guy. If I add 1.5 IQRs to him, and I subtract 1.5 IQRs from them, that will give me my boundaries of what's an outlier and what's not an outlier. So I need to figure out what those boundaries are. So I need to figure out what 1.5 IQRs is. So 1.5 IQRs, sorry, let me rewrite that. 1.5 IQRs is 1.5 times 6, right? 1 IQR is 6. 1.5 IQRs is 1.5 times 6. What's 1.5 times 6? 9. Right, if you have $6 and someone has 1.5 times what you have, they've got 6 plus half again. 6 plus 3, they got $9. So 1.5 IQRs is 9. So here I'm going to subtract 9 for minus 9, and here I'm going to add 9, 10 plus 9, to figure out what these boundaries are. This boundary is going to be 19. This boundary is going to be negative 5. Do any of them fall outside that boundary? Do any of these numbers fall outside the boundary? Yes? Sarah's saying yes. Which ones falls outside the boundary, Sarah? 20. 20 is outside this boundary. Does that make sense? So really the boundary, maybe I should move the boundary over. But yeah, so we have our lower limit, lower edge, I guess you could say, is 4 minus 9. Negative 5. And the upper edge is 10 plus 9, 19. And 20 falls on the outside of there. So it is an outlier. So all inside here, these guys are not outliers. They may be unusual, right? If you get over here, they may be, you know, unusual, but they will not necessarily an outlier. If you're really out there, then you're an outlier. Okay? You guys need to you need to go ahead and do the lab problem at the bottom of the page. I think it's 7, I'm not sure.
Yeah.
Yep, here we go. I gave you the 5-number summary, by the way. This is a 5-number summary, so you already have your Q1 and Q3. You don't even need to calculate it, it's given to you. Here, I'll give you that picture though, in case you want it. Q3. So an IQR. So I think you guys are this far so far, right? You found your IQR, subtracting the Q3 from Q1, or Q1 from Q3, and then you multiply that by 1.5. So you get 1.5 IQRs. That's the number you're going to add and subtract from Q1 and Q3 to get your boundaries. So here, this is going to be 1D3 minus 57, which is negative 34.
Yeah.
And this one's going to be 61 plus 57, which is going to be 118. So negative 34 to 118, those are our boundaries. Make sense? Is 120 an outlier?
Yes, you got 118 now.
So yes, because it's more than 118. Is 14 an outlier?
No.
No, because it's right inside of this range.
On an exam, do you want us to explain, or is it yes or no? Sufficient? Almost otherwise.
You, on the exam, I'm actually not going to ask you that part on the exam. I might have you find an IQR itself, but I wouldn't go to this extreme. This is going to be on your project though, so what you'll need to do is you'll need to list all of your data values that are outliers. So I would do the other way and say, do you have any outliers? If so, list them and you write what they all are. Yeah, that'll be part of project part 5. Project, yeah. Okay. All right, now put that one away and pull out chapter 5. Okay, chapter 5. You guys, we're gonna go overtime if we don't focus and pull this together. You guys ready? Okay. Great. So Derek, why don't you go ahead and read? This is your first fill in the blank thing. Derek, go ahead.
A random variable RV is a variable whose values are determined by chance. A discrete RV assumes a finite number of values between 2 points and can be counted.
Right, discrete can be counted. Keep going.
A continuous RV has infinite possible values between 2 points and comes from data that is measured.
Right, because continuous variables are things you measure. All right, so good. You guys filled in that first blank.
Yeah.
Here's the second blank. Andre, go ahead.
The discrete probability distribution consists of the values of a random variable can assume and the corresponding probabilities of the values.
Right. Discrete probability distribution. Okay, keep going.
The sum of the probabilities of all events in the sample space add up to 1. Each probability is between 0 and 1 inclusively.
Perfect. So, if I roll a dice, what are my possible outcomes?
1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. So my discrete probability, it's discrete because I can't have, I count the dots, I don't measure them. And I list every possible outcome. Then I list the probability for each of those outcomes. It darn well better up to 1 or 100%, or there's something wrong. Right, I've left something out. So if you have all possible outcomes and their probabilities, you're good to go. That's a probability distribution. If I flip 6 coins, take a coin, I flip it 6 times. How many heads could I get?
3, 6.
I could get 6. What else? 0, or any number in between, right? 0 through 6. How many do I expect to get? 3. So if you look at this, 3 is the most common. All right, here's my graph. You can do a graph of it as well. 3 is the most common. You can also get 2 or 4. A lot less likely is 1 or 5, and really unlikely is 0 or 6. So this is a graph showing it graphically, which you'll have some homework problems on that as well. But do you see up here where it says number of heads and all the probability of each of those, all the probabilities of each of those? So let's take a look at this one. 30 seconds with your neighbors. Figure out whether these could possibly be a probability distribution and why or why not. With your neighbors, discuss.
Oh, there you go.
All right, Brandon, what did you guys get? What did you guys see for the first one?
Yes.
Yeah, it could be. Right? Why? Yeah, if you add all those up, you get 1. All right. Carl, what did you guys see for the second one?
No,
No? Give me one reason.
it's because you can't add them up and get 1.
Right, if you add them up, you do not get 1. Adam, give me another reason. What's another reason that this one can't be?
The -8?
Yep, can't have a negative probability. Make sense? Everybody all board? Great. Child daycare. Patrick, can you read?
A child play in daycare. In a popular daycare center, the probability that a child will play with the computer is 0.45. The probability that he or she will play dress up is 0.27. Play with blocks is 0.18, and paint is 0.1. Construct a probability distribution for the data and draw a graph for its distribution.
Not worry about that, then just construct a probability distribution for the data. So, should be like this. Should have x and probability of x. So list out your possible outcomes. What could possibly happen? Child could what? Play with the computer. What's that probability? What else could they do?
Dress up.
Dress up. Fill in the rest of it. the other options? Blocks and paint, probability of dress up is what? 0.27. Blocks is,
118.
and
1.0.
1.0.
Yeah.
Yeah, 0.10. Okay, good. Now we're going to talk about the mean, which is also known as the expected value. Expected value. Mean, they are the same thing. The mean is your average. What do you expect to get? The average. On average, you're going to get blank, right? That's what you expect to get.
Yeah.
So what is it? It's basically a weighted mean. You take every x value, you multiply it by its probability, its weight, and then you add those up. You divide by the sum of the weights. But what's the sum of the probabilities always going to be? 1, or 100%, right? So you don't even have to divide by 100% because it's just divided by 1. It's the same, you get the same thing you start with. So multiply every x value by its probability and add them up. Done. Here's an example. Say I have a box. It has a 1, a 2, and a 3 in there. If I draw, on average, over and over again, on average, what do I expect to get? 1, and 2, and a 3 in equal numbers. So what should my average be on average, if I average them? Let's do this. Your grandma, every time you visit your grandma, she will present you with 3 envelopes. One has $1 in it, one has $2 in it, one has $3 in it. You get to pick an envelope every time you go and when you leave, you get to take an envelope and take it home with you. There's always one that has $1, one that has $2, one that has $3. On average, how much are you going to make going to grandma's? What, $1, $2, and $3? If you're making $3, you're drawing really lucky all the time. $2. Does that make sense? Because every time you draw $1, the next time you might be just likely to draw $3. Does that sort of make sense? And you draw $2 in your 2 as well. So on average, it'll be $2. How do we find that? $1. What's the probability of drawing of $1? A third. Plus $2, probability of drawing $2, 1/3. Plus $3, probability of drawing $3 is 1/3. 1 times 1/3 is 1/3. 2 times 1/3 is 2/3. 3 times 1/3 is 1. Add those up, you get $2. Good? All right. Great. Here's another example, rolling a dice. So here are, obviously, we did this earlier, I showed you guys earlier, all the possible outcomes for rolling a dice and their probabilities. So I'm going to take every x value multiplied by its probability. 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. So if I add those up, I'll get 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. So on average, I will get 21/6 or 3.5. So my expected value, my mean and expected value are the same thing, is 3.5. Let me show you how we write expected value. So we write that as expected value of x. That way when you see on the exam, you won't get panicked about what that is. Expected value of x. Same thing as the mean, 3.5. And that kind of makes sense, because for every time I roll a 1, I should roll a 6. And 1 and 6 average to 3.5. For every 2, I should roll a 5. That should average to 3.5. For every 3, I roll a 4. Those should average to 3.5 as well. So that makes sense if you think about it. So you guys need to do this problem on your worksheet. is the last thing we're doing before we leave. Let's get a reader for it. How about, Sarah, go ahead, read.
Grab bags. A craft store has 25 assorted grab bags on sale for $3 each. 15 of the bags contain $3 worth of merchandise. 6 contain $2 worth of merchandise. 2 contain $5 worth of merchandise, and 1 contains $10 and 1 contains $20 worth of merchandise. Is it worthwhile to grab a grab bag? Find the mean value of your profit or loss for this probability distribution.
Great, so I'm walking into this store. How many grab bags does it have? 25. I'm buying one. I want to see, I want all the, I don't care what I get. I want all the crafts anyway, so it doesn't matter. It'll be worthwhile to me, whatever it's worth. And I want to know, is a grab bag a good buy or not? So I buy one. What could possibly happen if I buy one?
$3.
I could get something worth $3. Does that make sense? What else could happen?
$2.
I get something worth $2. So these are all my possible outcomes. What's another possible outcome? $5. Good. 10, 20. So those are your outcomes, your X's. So make your probability distribution table. Figure out what those are, and then find the probability of each of those outcomes. All right, so here are all your possibilities here, right? $10, $20. So what's the probability that I get a $3 bag? 1,500%? 15 out of 25. $2 bag? 6 out of 25. $5? And the last two, 1 out of 25. So then you're going to do your weighted distribution, right? And you're going to do 3 times 15 over 25, plus 2 times 6 over 25, plus 5 times 2 over 25, plus 10 times 1 over 25, plus 20 over 1 over 25. And you'll end up getting $3.88. Yes? You're so quiet.
So they're giving away money.
Yeah.
Why are they doing that?
Well, because they want you to, they want you to buy, because it's more interesting. Like maybe you'll buy a grab bag and then they sell stuff. Their whole point is to sell stuff.
I thought it was like gambling where you think you're
No,
getting
no,
money,
no,
but they rip you off.
No. Yeah, no, it's not money. There's not money inside. It's merchandise, and they're trying to sell merchandise. So they can probably sell you $3.88 worth of merchandise for $3 and still make a profit. Yeah. Yeah. If you're doing a business